Hello folks, this is 2023 October November paper 1-3 and the question number is 34. As you can see, the question is concerned with the chapter of current electricity. It says that a cell of electromotive force EMF 3.0 volt, so this thing will be E, and the internal resistance is 0.50 ohm, this is small r, is connected to a variable resistor. So we have the source here with a resistance small r with a variable resistor, a voltmeter. So the voltmeter is connected across the variable resistor as shown, and an ammeter. The ammeter is in series with the circuit. The resistance of the variable resistor is varied. Yes, the symbol shows that. The reading on the ammeter I and the reading on the voltmeter V are recorded. So which graph shows how V varies with current I? So we have to show the nature of the graph. So as we know that when we have a resistor, when we have internal resistance, and when we have a source, the equation is E terminal is equal to E minus IR. The terminal PD is equal to EMF minus product of current and the internal resistance, which can be changed as V equal to minus RI plus E. So if I draw a graph of I in the x-axis and V in the y-axis, the graph should be a straight line, which has got a negative slope, and a positive intercept. So all the graphs are of the same pattern. They have got a negative slope, constant slope, and they have got a positive intercept as well. So now in this graph, if I set I equal to 0, because in all these graphs somewhere I is 0. So if I set I is equal to 0, then I have V is equal to minus R into 0 plus E. So this becomes equal to E. And here E is given as 3 volt, 3.0 volt. So what I must have is V should be equal to 3.0 volt when I is equal to 0. So when I equal to 0, I equal to 0, I equal to 0, V should be 3 volt. So that means this thing disqualifies and this thing disqualifies, only this and this still qualify. V equal to 3.0 volt. Then next set, let us set that V equal to 0 in this equation. If I set V equal to 0, then I must have equal to minus R I plus E. So this gives Ri is equal to E, or this gives, what it gives is I is equal to E by small r. And here the value of E is a 3.0 volt, 3.0, and the value of small r is 0.5. And this definitely gives us 6.00 amperes. So when V equal to 0, V equal to 0, V equal to 0, the current should be 6.0 amperes. So in that case, this and this is correct. But this is already disqualified. So this qualifies according to both criteria. So this should be the correct answer. This also incorrect. This should be the correct answer. So correct choice is choice number C.